Hello, this is Sapience Education. I welcome you all in a Sapience Education. Today I'm going to solve NCERT solution for a mechanical properties of the solid, okay? And totally as per the latest syllabus. In this question, question number 8.1, a steel wire of a length 4.7 meter and cross-sectional area 3 into 10 power minus 5 meter is there. So let us consider there is a steel wire and it has a length which is equal to 4.7 meter, and the area of cross section, that is A, is equal to area for the steel is equal to 3 into 10 to the minus 5 meter square. Now there is another wire, but it is of steel and it is of copper. So copper has length of the copper LCU is equal to length of the copper is 3.5 meter, and the area of the copper is how much? Area of the copper is 4.0 into 10 to the power minus 5 meter square. Now we need to find what is the ratio of Young modulus of elasticity. So we need to find but the condition for this both the wire is that they have applied a same amount of the force. They have applied a same amount of force. So they have applied a load or a force as F. Here also they have applied a load or a force as F. And one thing they have a common is that delta L, that is change in length for both the wire, is same. Okay, so they are in the question they are asking that the change in the length is same. So what is the ratio of Young modulus of elasticity? So they are asking y Young modulus of elasticity y of steel to the power y of copper. Okay, so let us do one by one. So before that we need to understand that stress is proportional to strain. So stress can be written as Young modulus of elasticity into strain. Stress can be written as force by area, and this is equal to Young modulus of elasticity and change in length by original length. Now from here we can also write a force by change in length is equal to y a by L. Now one thing they have given that for both the object, the force by change in length is constant for both the thing. So if this is constant, so we can find y for a copper by area of for the copper is divided by L for copper is equal to y for steel into area of the steel divided by length of the steel. So from here what we can guess, we want y is steel, y as divided by y copper y steel by y copper. So y steel by y copper can be written as area of the copper into length of the steel divided by area of the steel into length of the copper. Now the data they have given, what is the area of the copper? 4 into 4.0 into 10 to the power minus 5. And what is the length of the steel? Length of the steel is given as 4.7 meter. Now area of the steel is equal to 3 into 10 to the power minus 5 into length of the steel is how much? Length of the copper is 3.5. So this will get cancelled out. So this will be 4 into 4.7 divided by 3 into 3.5. So finally our answer will be 1.79. So this is the ratio. So I hope you have understood this question. So this is the ratio, the required ratio for the Young modulus of elasticity from steel to the power to the copper. Now next question, let us consider in figure 8.9. so this is the figure they are talking about. In figure the is shown that the strain stress curve. So this is a strain and this is stress curve of the given material. What are the Young modulus and approximately yield strengths? Young modulus of, what do you mean by Young modulus? So Young modulus, if you want to find a Young modulus, so we know that Young modulus is equal to what? So as we know that the formula, stress is equal to Young modulus of elasticity into strain. So from here Young modulus of elasticity is equal to stress by strain. So from figure it means that stress by strain means what? We want this, the slope, because this is stress sigma and this is strain. So we want slope. If you want to find a slope, so how you will find the slope? So if you want to find a slope, you have to find this ratio, either this ratio, any of the triangle. You take the triangle and you take the perpendicular and the base, you will get the ratio. So if I am considering this triangle, so smaller triangle only, so you can take any triangle, any of the triangle. So what is this length? This length is 150. So the stress value is how much? 150. Stress value is let us write here stress value. This is equal to 150 into 10 to the power 6 Newton per meter square, because they have given stress in the form of 10 power 6. And what is the strain for the corresponding triangle? So we have stress is equal to 0.002. So when I will divide this, so what we am going to get, uh, this will become 75 into 10 to the power 9 Newton per meter square. So this is the required answer for part A. Okay. Now for part B. Part B, what they are? Approximately yield strength. Yield strength. Yield strength. We want yield strength approximately. Okay. So yield strength can be written as, so we know that before that you should know that what was stress strain curve, what was yield strength. So let us consider this is stress strain curve, and there is a graph between these two for any material. So see here. So this is the yield point, okay, and this is ultimate point, ultimate strength. So the stress corresponding to yield point is known as ultimate yield strength, and stress corresponding to the this point is known as ultimate strength. So if we have only in figure if you want to see that in figure they have not given point like this, so but we can make sure that approximately yield strength and ultimate strength both will be the same point, because they have not given the value, further value. It means that it may happen that the both the point may collide. So if both the point may collide, then what will happen? We need to find the right choice or the yield strength. So ultimate strength, if you talk about the ultimate strength, so ultimate strength will be it will be 300 into 10 to the power 6 Newton per meter square. And if you talk about the yield strength, that is sigma yield strength. So this will be also equal to same value we can approximately, because I also don't know what will happen in the future. So but we can assume that approximately the answer will be this 300 into 10 power 6 Newton per meter as per the question, because they are assuming that you should write this answer in the question. Okay. So I hope you have got the solution for question number B. Solution is this. Now let us go for a third question. In third question, the stress strain graph for a material A and B are shown in a figure. So this is a one graph, this is the A, and this is B graph. Okay, the graph drawn in the same scale, so both are drawn in a same scale. So which material have the greater Young modulus of elasticity? So we know that what is Young modulus of elasticity, just now we have done. So Young modulus of elasticity is equal to stress by strain, that is equal to slope. So when we check out which has more slope means more slope means more Young modulus of elasticity. Okay, more Young modulus of elasticity. Okay, so which has more slope means what? Angle. So let us consider this is the angle, let us consider this is the angle. So the more angle means more tan theta means more slope. So when we observe carefully both the graph, so what you will observe that this is more angle. See here, it is more it has more slope. See it has more slope, but it has less slope. So A has a more slope. Since A has more slope, so A will have greater Young modulus of elasticity. Young modulus of elasticity. Okay. Now let us talk about B, which of the two is stronger? Stronger means what? Strength. So when we talk about the strength, so which has more strength? So it is like yield strength. Which has more yield strength? So from figure, when you draw the line, so let us draw the line. So which has more strength? See here, the value for a B has more strength, but for this because we always check strength from the curve when it leave the straight line, when it leave this straight line. Okay, so here it means that for A we have this amount of yield strength, and for B we have this amount of yield strength. So from here we can consider, we can see that yield strength for a B is greater than yield strength of A. So that's why our conclusion is that the B is more stronger than A. So I hope you have understood this question. So I hope you have understood this question. Now let us do question number 8.4. Read the following two statement carefully and state that with the reason if it is true or false. So first statement is Young modulus of a rubber is greater than that of the steel. So let us consider here what is Young modulus. So Young modulus means what? You know that stress is proportional to you know that A stress is proportional to strain. So stress is equal to Young modulus of elasticity into strain. So Young modulus of elasticity is equal to stress by strain. Okay, so stress by strain. Young modulus of rubber is greater than that of the steel. So how we can see here? If we draw the graph between stress and strain, so this is stress and this is strain. So what will happen if we apply a force on rubber? Let us assume that this is a rubber and let us assume that this is a steel. So let us assume that we are applying a force of 10 Newton here also. So here also 10 Newton. per meter square. Same, they have same cross sectional area, so the stress you have applied for the both is 10 newton per meter square. Here also 10 newton per meter square. Now for same stress rubber will elongate more, rubber will elongate more, elongate more, right? So if rubber will elongate more, so let us draw the curve for a rubber as well as uh, steel. So for steel, let us consider this is steel, and if for the same space rubber will elongate more, so this is okay. Now see, here the slope of the rubber is less, but slope of the steel is more. So it means that Young modulus of elasticity for steel, y steel is greater than y rubber. Next is stretching a coil is determined by the shear modulus. Now next is stretching a coil is determined by shear modulus. See, this is a coil. If we stretch it, so how you will determine? So there are three type of modulus: Young modulus of elasticity y, shear modulus g, and shear modulus, that is sorry, tau, and volumetric modulus, that is g. Now shear happens whenever there is a change in a shape. Change in shape happens. So if there is a change in a shape happens, then what will happen? We have to apply a shear force. So here when you apply a force, there is no stretching, right? But there is a change in a shape. So due to change in a shape, so our solution would be that here, due to change in a shape, shape of coil, due to change in a shape of a coil, here shear modulus will be applicable. Shear modulus will be applicable. Okay, so I hope you have got the answer. Thank you.